I can hear aliens going on.
It's Elon Musk's son. Hey Mike, your microphone is broken or not working.
You've gone all alienated.
I can't understand you now.
Come in, aliens.
Is that any better now?
Hey.
Yeah?
Yeah.
Okay. Right. So, electrical assignment 2. Analyze the operation and performance of semiconductor devices and explain and evaluate the difference between analog and digital electronics. Issued 26th of May and hand-in date is Tuesday the 30th of June. Yeah? So, looking at the tasks, you will learn and outcomes. Describe the basis of semiconductor action and its application to simple electronic devices. And learn an outcome 4, explain the difference between digital and analog electronics, describing simple applications of each. Okay, so task 1, part A, is pass. Yeah. So you're going to do a description of the behavior of a silicon PN junction diode in terms of semiconductor behavior, including but not restricted to those topics mentioned there. So I need you to talk about doping, about the depletion zone and how it changes, forward and reverse bias. So an annotated graph of the typical output characteristics should be included, and talk about the forward threshold voltage and the reverse breakdown voltage. Okay. Task 1B is also pass. Using suitable circuit diagrams, describe the action of the following devices. So we want what they actually do in a circuit in terms of the PN junction, how they operate as a full wave rectifier in a power supply. We've just been through that. A 12-volt Zener diode as a simple voltage regulator in a power supply. We'll be looking at that next week. We have touched on it already. And the bipolar junction transistor as a switch. That's not looking for PN semiconductor theory in that task. Okay, it's not looking for that. It's the action of that device, how it works in a circuit. Task C is not pass, and nor is task 1C is not a pass, and task 1D is not a pass either. Okay? But in those, so in part C, you are being asked to talk about semiconductor theory in terms of the bipolar junction transistor, depletion, and the enhanced mode MOSFET. So it's asking you to talk about the theory of the channels in the two MOSFETs and how the PNP or NPN part of the transistor works. Part D, carry out suitable research to analyze the advantages and disadvantages of both bipolar junction transistors and enhanced mode MOSFETs as a switch. Yeah, so you should include typical applications of both devices, including uses other than as a switch. So they can both be used as a switch, but they can also be used for other applications. Task 2, this is like learn and outcome 4. So part A is a pass, pressure sensor, instrument range has an output in the range 0 to 10 volts. Pressure range is 0 to 10 bar. Suitably annotated diagrams to explain the differences in the way analog and digital systems would represent the voltage output. So we covered that last week. So asking you to outline how that analog signal is represented voltage-wise as a straight analog signal, and how a digital system would represent that voltage signal. Part B is not pass, but is asking you to research and explain the relative benefits of both analog and digital electronic signals in terms of their accuracy, their noise immunity, cost, and power. Part C is not a pass either, but using the pressure sensor from part A, analyze and evaluate the difference between the direct analog signal of 0 to 10 volts and the same signal represented by a 12-bit binary word of an A to D converter. So annotated diagrams will be expected. So we covered that last week as well. Part D is pass. So you're given the application of a strain gauge that provides an output in the range 0 to 200 millivolts across its sensing range. In order for it to be interfaced with an instrument to display an output, this signal needs to be amplified to have a range between 0 and 5 volts. Going to incorporate an operational amplifier like that in figure 1. So you're being asked to explain the general characteristics of a typical op amp, such as that in the diagram, and calculate a value for the feedback resistor RF that will give you the gain to go from 200 millivolts up to 5 volts. Yeah.
Yep.
So that's that task. And then part E, that is pass. So produce a complete truth table of all the options and then end up with a Boolean expression, not a simplified one in this task. So you're not expected to simplify it for the logic circuit of figure 2. So we want a Boolean expression and truth table for the output Q. Yeah. And a short explanation of what that circuit would do. Part F is not pass, but it's asking you to analyze the result of the truth table from part E using Carnot maps, a Carnot map to provide a simplified Boolean expression and revised logic circuit diagram. Carnot map should be clearly annotated and explained as to how you obtained the resulting expression. Yeah, so you can actually simplify that circuit quite a bit, like we did with the example of the boiler circuit that we did in the weekly sessions. Okay, and then moving to the last page here, LO1, we've been through those. So as we've just been through, pass P3 to describe the behavior of a PN junction in terms of semiconductor behavior. P4, action of a range of semiconductor devices. So that's the action of those switches and those diodes. Explain the difference between analog and digital electronics. So you've been asked to research there, and explain amplifier characteristics. That's the op-amp explanation. For a merit, you need to explain the operation of a range of discrete semiconductors in terms of simple semiconductor theory. So that's kind of adding the semiconductor theory to the actions here. M4, explain the benefits of using analog digital electronics. So that's where you're going to research. And D3, if you want distinction, analyze the performance of a range of discrete semiconductor devices in terms of semiconductor theory. So that's where you add in the semiconductor theory. And D4, evaluate the use of analog and digital devices. So this is where you're producing the revised logic circuit diagram, and it's where you are the pressure sensor and how that can be represented by a 12-bit binary word. Okay, anybody got any questions about that assignment?
Looks like fun.
Did you say 2B was a pass, Mike? I missed 2B, sorry.
2B, hang on. No, 2B is not pass.
Can you just quickly go through and just say all the passes once again? Just
I've written them all down. I can put a picture in the group chat.
That's great.
There we go. I'll run through them once more. Pass is task 1A,
1A,
1B,
1B,
yeah, and
2A.
it's 2A, 2D, and 2B.
Beautiful.
Yep. And
Yep.
the date for a draft handing of that assignment is Wednesday, the 10th of June.
Beautiful.
Yeah, and the final handings on the Tuesday. Well, it's up the top that date, isn't it? Okay. One more thing. We've got 2 more weeks of sessions left after this one. Yeah, so you've got the rest of the day to start work on this assignment, work on a maths assignment or Omal's assignment, whatever you wish. And after that, we've got 2 more weeks to tidy up any loose ends for you to ask questions and such like prior to you completing assignments by the dates given. Any questions?
Nope.
Nope.
Okay. Well, I will see you all at 8:30 next Tuesday morning for maths.
Awesome.
All right? Awesome.
All right.
All right then.
See you next week.
Have a good week. See you next week.
Bye.
So,
See ya.